So welcome back. Let's go ahead and just talk about a couple of installation things just to get you going in case you had some troubles. The problem some people ran into is when you install Revit, if you didn't happen to be on the network at the time you were kind of installing things, library files that you would copy down from the network and put on your machine may not be installed. How you can typically spot that, easier than anything, is if when you say new, and you say you're creating a new project, if it doesn't list some templates here, if it says just none and there's no other choices, that's a pretty good sign that you don't have a library. The other way that you can sort of spot it is when we say insert and we say load a family. Again, if there's nothing in that folder, you know you're sort of in trouble. So here's how you can do that, because you don't have to, or fix that. You don't need to go ahead and reinstall everything from scratch. What you can do is actually, all the stuff exists just out in a folder and you just need to find that folder. The problem with finding that folder is it's typically hidden from you in terms of where it's standardly installed. So you have to do a little convincing windows about how you get it. So in your C drive, you'll find that when you do all the installations, there's a couple of folders that are interesting. The Autodesk folder out here is actually full of all the installers. So if you're actually getting short on space on your machine and you're running out of like this space, you can actually delete this folder. That's just the installers that, you know, if you go through and say you want to change the features, if you keep all the installers here, everything's very handy and readily available. You can fix them easily. You might have to re-download it to fix things if you get rid of that. Or you might copy those off on an external drive or something like that, but you don't need to keep them on your main drive all the time. Okay. The other one that's sort of interesting in this whole scheme is under program data, which is a hidden folder. So the problem with hidden folders is you can't see them automatically. What you may need to do is, I always have to find where it is. Under organize for me, I think it's folder and search options. You have this whole notion of the view and what should be shown in the view. And typically what's happened is it says don't show the hidden files. So you won't even see program data. If you can't see program data, okay, we can't put things into it. I tend to show those just because I need to get in there and mess around every once in a while. So I show the hidden files. They show up kind of grayed out just to kind of give us an indication that they're different. And where the library actually lives is under program data, Autodesk, and then if you go scrolling on down in this list, it's actually Revit 2013, right down there, RVT 2013. So what you want to do is, if you're going through and changing things, don't go ahead and change out the whole file. The license and the dictionary, that's all sort of probably set up just the way you want it to. You don't want to replace the license thing. It's the part down here. It says libraries and family templates. Templates, those are the three that are really the most interesting for you to change. And what you got to do is, if you have that thumb drive full of stuff, is just go ahead and copy and place things in here. You'll just find all the library things are in here. Those templates, those are the templates for the construction versus the electrical versus the residential. You may also want to do this if you've installed a localized version and you only have the metric pieces. I'll pass behind it. Then you want to get the imperial pieces, or you might want to do it the other way. If you have all the imperial pieces because you downloaded it here in the US, if you want to get the metric pieces, you can get those and install them. Just kind of get pieces that sort of feel comfortable for you. And we can kind of swap those around a little bit, but you don't need to install that all from scratch. Okay. Once you've put it out there, how you actually access those things, in case you need to point it, is under the options. You'll actually find that all those different file locations are specified here. So let's show you where they live. They are all hanging around in file locations. So the notion of really, where is the path to store your files, or where should look for the family templates? They're all kind of hanging out in here. This is where to find the project template files. So the way to do this is, after you've gone ahead and put that into the program data folder, go ahead and add in the different templates you want to use, kind of point to where the library is. Okay, you basically want to get it all set up by pointing to things, and then it'll show up automatically inside the open load dialogues. Okay, so you might need to kind of set that stuff up too. We can give you some help with that if you're having troubles. Okay, let's talk about what we want to talk about today. And we had a couple of kind of interesting things come up. We want to talk about really things that are going to get you ready to go ahead and kind of design your own little field research station and be able to document that. So I want to get through the whole notion of basically working on floors and roofs. We sort of got through roofs and made it that far in the last session. We sort of went off on a path, which I think is actually a pretty good path, to really kind of take a look at the issue of placing windows, but in terms of doing that, thinking about how we copy, how we array, how we control the spacing of different things like that. So I think that'd be good stuff to go through with you. It's good, just basic Revit editing skills that'll really apply. I'll show it to you in the context of windows and furniture, but it'll really apply to anything you place in terms of getting a little more control over that. So what I'll do as a starting point is, let me just go ahead and I'm going to create a very simple little building, something like we did yesterday, and get ourselves started. If you want to work on the building that you were working on yesterday, or work on your own field research station if you started that, go ahead and open that one instead. Just whatever it is you want to do. I'm just going to open up a brand new one. So I'm going to go to the architectural template and just get started. So here we are hanging out. We are basically ready to start placing things. In terms of the drawing area, just as we place things, a good thing to note is that this area between the different elevation markers is a great place to get started, because the elevations are already set up at those locations. So if you put things in the center here, the elevations will already pretty much be centered around where you want them to be. If you have things hanging out into other places, that's okay too. We might just need to sort of adjust the cropping on your elevations to get things into view. But in general, I tend to put things sort of in the center. I'm going to choose an architectural wall. I'll again choose one of the different wall types. We talked a lot about how to go through and create some different wall types. So I'm just going to go for that, like brick on metal studs, and place a wall down. Again, the big important things were I'm going to choose the height that I want it to be, so not just let it be an unconnected 20. But I'll just start drawing. And again, I'm not going to worry an awful lot about the precise dimensions right now. Notice I get the little inference lines indicating that I'm at an interesting corner. I'll pull that on up, close that, and I think we're in good shape. Let me zoom on in here a little bit. Now, I'm looking at what look like fairly boring walls right now that don't give me very much information, because what's happening is I've currently set to a coarse level of detail. The coarse level of detail hiding a lot of information, just to kind of make it a little faster to display. If you'd like to actually see the information about the walls, you can turn that up. There's a little widget down at the bottom there, a little menu that lets you choose either medium or fine will show them, and then you can actually see the walls. And what I often do is I'll often even go through and just turn on shading, because I actually like to see the colors. So it just gives me a little more information to help me sort it out in my own mind. Now, your screen may or may not look like this. Let me tell you about kind of a visual display mode you can choose, and you can choose which way you prefer. By default, Revit shows with something turned on where it's showing you the actual thickness of the lines relative to the way they would be plotted. So what happens is the outside surfaces of the walls, they're showing up as thick lines. The interior surfaces, they're showing up as thinner lines. And if you actually plotted it out, that's the kind of line that we're actually going to get when it comes off the plotter or it comes in the print. Okay, now, this is kind of okay in terms of plotting. As I'm working, though, it gets a little bit tough sometimes to see what I want to see, because even right in here, like there actually is a layer of sheetrock there. You just can't see the layer of sheetrock because the lines are so thick relative to the weight. Well, or the actual thickness, you don't see them. So what you can do is you want to switch that around. You can say, switch to the View tab. And under the View tab, there's something called Thin Line Mode. And if you turn on Thin Line Mode, the only real advantage to it is it'll actually show you, like, 1 pixel thick lines as opposed to thick lines. Yes?
Oh, can I create a new level?
Oh yeah, if you want to create a new level, what you will do is, we always do it in one of the elevation views, so I can go to any of them, like north, south, east, or west, any of those. And right now I have level 1 and level 2. If I want to create a new level, what I do is, it's on the architecture tab. There's a tool way over in the datum section called the level tool. And if we choose it, we can just draw from left to right, create a new level 3. And then we can adjust the height. So if you need multiple stories, you can just go ahead and add new levels. When you add new levels, notice they show up in the project browser here too. So now we have floor plans for each of those different levels. Okay? So I'll go back to my floor plan here. I got some nice exterior walls kind of hanging around.
Let me go ahead and draw some interior walls tool just to give us some stuff to work with. I'll say, oh, interior walls. Let me see if I can choose a nice type in here. These are all the commercial ones. In the template, if you've opened the template that's out there on the L drive or that you downloaded, you might see that there's some different wall types, some ones that I think are more common for wood frame construction. So there's things like the wood frame wall with stucco, the wood frame with siding, wood frame with shingles. I'm just going to draw some interior walls here. And what I want you to note about this is that the walls try to do a good job of healing up. So for example, if I come down to this intersection and look, you'll see that the framing layer has joined with the framing layer out there. The sheetrock layer is kind of wrapping around. It tries to do a good job. If it says an intersection or a join, and it thinks the materials are the same materials wrapping around the intersection, it will join them together. It'll try to do what you actually do in the field, and you get it up honoring that. Yeah. If things aren't quite lining up, it tends to be that there's a problem with your wall join. Your join's not coming together very, quite cleanly in the wall, and that happens. So go ahead and give yourself some walls. Then what I got started with last time is just this notion of windows and how to place some windows. People have some questions about how they're just going to control the placement of the windows and how to think about them. So let me kind of show you a couple tricks in terms of placing. We'll do it in the context of windows, but it'll really be good editing tips for just anything that you're going to go ahead and create. So to get to the windows, and I'll do it for windows, but the same would be true of doors, it would be true of furniture, anything that's a component. What I do is I go to the architecture tab. Let me go back over here. I will choose either the window or the door or just a general component. I'll choose windows for now. You'll see that once again I have some types over here in the type selector, and they may or may not be the ones that I want to work with. I only have the fixed ones here. If I would like to load in some more windows, what I could do is go to either the Insert tab. There's actually another tab that's kind of hanging off the side of the screen here, which is like for drawing or placing the windows. But let me open and say Load Family. What the Load Family will do is it'll take me out to the library and let me go looking for things. Now, again, if you don't have this, if you're going to a US library and it's all empty, this is a sign that you didn't get the libraries and you want to copy them off that thumb drive. Okay. But if you do need the library, or you do have the libraries, come on up, go down to Windows, take a look at what you would like to bring in. Now, in terms of what's going on with the windows, it's actually pretty straightforward. You can grab as many different ones as you want to. You can choose individual ones, or you can grab several. I'm going to go through and grab, I'll get the double hung window. I'm going to get the one with trim, too. If you want to get several, you can Control-click and get them. I'll get the fixed with trim, maybe a casement. Maybe a casement with some nice mullions in it, or some grills in it. I want that. Maybe in the art shop. I'm just going to grab a selection of different windows. Now, there's not really a huge penalty for dragging these windows in. They do have, they take up some space. Okay, and the more you load in, the bigger your file will be, the more that it has to maintain in memory. In general, you should only load in things that you want to or are likely to use. That you want to use now, or you think they're likely to use project addresses. Okay, because everything you load in sort of loads it down a little bit in terms of what I'm using your screen. But, I'm not too worried about a couple different sorts of windows. What you don't want to do is watch out when we actually start doing structural elements. You don't want to load in the entire steel library, something like that. You've got hundreds of different elements there, and that'll really bog things down. But in general, a couple windows here and there, that's not going to bother you in terms of how this needed for that. So, I'm going to go over here, take a look at some of these windows. Let me go ahead, I'm just going to start with the fixed ones. We'll put those in there first, and then we'll start messing around after that. I'm going to grab some windows, let's say the 24 by 48s. And I'll go placing them in here. Yes?
I was just going to ask, say you imported some libraries like, I don't know, structural steel or whatever, and it turns out later that you didn't want that kind of steel, can you delete it?
Yep. Anything you load in, it'll show up here in the browser under Families. And anything you don't want, we can basically take out and we can delete it. and remove it. There's also a really cool tool just purging everything you haven't used. That'll go through and like just clean out the house. Okay, so a lot of choice there. Okay, so I'm going to put that window in here. As I place my windows, the big thing to watch out for when you're placing windows is just watch the location of your cursor. Because the cursor is going to indicate which is the inside versus the outside. So I'm always going to try and like hold to the outside. So I'll put a window in here. I'll put another window in here. Maybe another one over here. Okay, and we'll get started. So now, as we go through and putting these different windows in here, there's a lot of things about the windows that we can go ahead and customize and start changing. For example, if you go clicking on the window, actually one thing that I typically pay attention to even before I place is this notion of the head height. The head height is actually, it's related to the sill height, and this kind of that's the relationship based on the height of the window itself. That's an instance parameter, and as an instance parameter, what that means is each and every one of these windows can have its own head height. So you can put them all at different heights, and that'll be fine. They're controllable separately. They can change multiple at the same time, but each one of those can be controlled separately. Okay, instance parameters are the first thing that appears in the properties palette. If you'd like to actually change something about the type of the window, which is kind of going one step deeper, we say edit type. And when we do, we're changing something that will not only edit this one, it will actually edit all the things that share the same type. So, if I, for example, look at this fixed window and take a look at what's available, you'll see that there's the height, there's the width. There's also this thing called the window inset. Let's play with that for just a second. With this fixed window right here, you might notice that the glass is currently way out towards the outer edge of the window right now. Okay, and that's a good way to do it. We can go ahead and have it only 3/4 of an inch of a recess and have a big sill on the inside. If you've been walking around looking at the Stanford buildings, though, you'll find that we actually do it almost the opposite way here. We tend to actually have, it's actually very deep window sills on the outside, and the glass is actually recessed very far back in. Okay? And in the old stone walls, that seemed like an appropriate kind of construction. You can kind of choose just which way you want to do it. On the Y2E2 building, they're all recessed about 5 or 6 inches, so the windows are a little bit back from the wall surface. And if you want to have an accurate model with something like that, you can control that with this window inset parameter. So currently it's set to 3/4 of an inch. If I'd like to go ahead and pull it back to, so 8 inches or a foot or whatever it is you want to put in there, when we apply that, you'll see that what's going to happen is it's going to affect all of the different ones. Because all the ones that have this 24/48, they are all going to share that same parameter. So you got to always think carefully about whether you want it to affect all or just some. Yes?
When you say that place the window that you're touching is on the outside of the window, what if you're not sure? How do you tell it?
Oh, if you click on a window, like even this window right here, there'll be a little arrow on it right now, and you can flip it by just kind of clicking that arrow. So,
Right, but if the arrow's on the outside of the building, does it stay the right way?
yes, yeah, the arrow should always be on the outside. Okay, so I have this one window type. I have this deep inset window. That's kind of cool. If I want all my 24/48 windows to be the deep inset window, that's what I have right now. If I want to have some variation, if I want to have some that are deep inset and some that are sort of more surface windows, okay, what I could do is actually, as opposed to just having a single type here, I could create 2 different types. And how I would do that is, and we'll get very used to doing this together, we'll always say just duplicate it. Let me go ahead and call this surface. Okay, and for this variation of the scheme, let me go ahead and give it a window inset that's only like an inch. If on the other hand I go 24/48, let me even rename that to give myself a little more clue about what it is. I can call it a deep inset. So now I got 2. Surface versus deep inset, and I have different variations on the same theme. The nice thing about creating different type variations is now, because I have them, I can say this one's a deep inset one, this one's a surface one. If I want to change it, I'll just switch it over to a deep inset one.
But you're going to figure out pretty quickly that you tend to like to have classes of objects that all have the same behaviors, because we don't really want to think about that as being a window with an 8-inch offset. That's just my deep inset window. Later on, someone may decide it needs to be 10 inches or 1 foot 1 or whatever it is. Just all the deep ones I want to have change and have the same behavior. Okay, now, as I've placed my windows, I've kind of placed them, kind of scattered them relatively randomly across the surface. If you want to have a little more control over how that works, so we have all these different windows. If you happen to be really good, you might actually get them nicely spaced out exactly the way you want, but I'm not so good about doing that. You can always click on a window, okay, and see what the actual dimensions are between the windows. And you can type a new value in there. Oh, I'll put 3 feet in there. It'll be spaced across. So I can space them out manually, and that'll work out just fine. Something that we often do with windows like this is we'll gang them together and mold them together. So if you actually want to have this window and that window just right up against each other, okay, and just mold right to each other, we have a really cool tool, and it's one of the general editing tools I'll be telling you about today that lets you align things. Let me show you how it works. So if you go through and select some objects, for example, I am going to go through and select the window. Okay. What happens is I'm actually looking at a special tab right now. You can't even see it, but it's the Modify Windows tab, just because my screen's kind of squishy. You'll actually have a Modify Windows tab. And why are we saying that? It's because I have a window selected right now, so it assumes you might be modifying it. Okay. It's going to show us here are some modify tools we can work with. There's the Align tool, the Mirror tool, the Array tool, the Trim tool, the Copy tool. A lot of different tools are out there, kind of very familiar to CAD users. And what I'm actually going to do is try using the Align tool. Because what I would like to do is have basically the edge of this window line up with the edge of that window, just kind of really be right on top of each other. The Align tool is a really good way to do that. Let me just zoom on in closer so you can get a better sense of what it looks like. So I'm going to choose the window. I'll say, let's grab the Align command. And now we're ready to basically go through and choose some different points on the window. And here's the way it works. With the Align tool in Revit, what you always do is you say, use this as the point of reference and pull things to it. It's always set the line of reference and pull things to that line of reference. So always choose where you want it to be and then pull you to me. Okay, so do that. Always choose that and pull things to it. So if I want to get these windows, if for example, if I want not the center line of the window, but the edge of the window right there to be the point of reference, I'll click there. And then I'll go off here and say, pull you to me. Pull it across, okay, and it'll lock them right up against each other. Actually, it'll join them together right now. Let's talk about the locking. The locking has to do with this. Sometimes we pull things there and we leave them kind of loose because we want to have them be able to move later. But in this case, it's sort of guessing, and you put that right up against it. That looks like you were trying to be intentional about this. Would you like me to lock those two things together so that if either one of them move, they always stay together? And you could always undo that, but in this case, that's probably a pretty good choice. Yeah, you were pretty intentional about getting those two things right on each other, so if you lock them, the nice thing is this. You can go ahead and take that window, and if you push the window, either one of them, they'll always stay locked together. So this is another one of those like examples of what I'll call, it's where we want to go through and not just sort of say this is literally where we want it to be. We actually want to encode what our design intent is, so that even if something changes, the intent will still be honored. It's always about trying to figure out what the design constraint was, not just the absolute answer. So even in here, let's kind of look at another one in here. I could go ahead and lock this one to that side. Someone asked last session about the whole notion, well, okay, locking them together is kind of okay, but what if I want to have a set relationship? I want to have them 6 inches apart or a foot apart or something like that. Okay, and we can do that too. Now, to do that, what we'll do is it won't actually be locking my line to your line. What we're going to have to actually do is sort of put in a dimension that sort of says what we want that relationship to be, and then we'll lock that dimension. That dimension will act as a constraint that we can use to kind of drive the behavior. Let me show you what I mean by that. I'll put another window in here just so I can get another example for you. So here's what we want to do. Okay, when you go through and you kind of choose a window like this, you notice that there's a dimension here. This is a temporary dimension right now. We can make it permanent. Okay, I can just click on this little guy and we'll put both of those dimensions in here. I'm actually just put a dimension in here. And how we would do that is, I'll go to, it's the Annotate tab. Annotations are all those things that show up in drawings. Okay, that only affect that one view, but dimensions are one of those things that also go in here, and they can actually drive geometry. So let's show you how that works. I'll choose the dimensions. I'll choose an aligned dimension. Aligned and linear look awfully similar. The big difference is going to be in an aligned dimension, well, in a linear dimension, what happens is if you have a wall that's kind of skew angle, it will always go through and put the dimension lines perpendicular, where aligned dimensions will follow the skew wall. That's what the big difference is. I'm going to do it as an aligned dimension. I almost always work with them. And I will say, let's go ahead and put a dimension here. Here's how dimensions work in Revit. What you do is you choose some point of reference on the object. For example, I'll get the center line of that window. I'll click on some interesting point on this object, again, the center line of this window. I'll pull it on out, and what happens is if you click into space, just into the drawing area, it'll drop a dimension. Okay, as it's dropping dimensions in there, and that's actually looking pretty good right now. If I click away, you'll see that the dimension stays. The nice thing about dimensions is they actually work two ways. The dimensions can be used for example, if I move that window, it'll report the dimension. I'm panning, wrong thing. If I move the window, the dimension will update. The other nice thing though is if you actually choose one of the windows, notice the dimension goes from being a black line, kind of reporting of something, to it's actually active. So you can use it to actually put in a value and drive the geometry. So dimensions work both ways. You can not only report, but you can also drive them. So if I want those two things to be 3 feet apart, I can put 3 in there, and they'll be 3 feet apart. Now the cool thing about dimensions is that dimensions can also go ahead and get locked. So for example, I got the dimension line right here. If you choose the dimension line, notice that it has the option of locking it also. So here's a little lock over there. And if you want to lock that dimension, all you got to do is click on the lock. You can always unlock it later. But if you have a locked dimension, the nice thing is, as you go dragging these around, it'll always honor that 3-foot relationship. Now someone was asking last time about this whole notion, okay, I got the 3-foot relationship in there, it's a nice constraint, I'm using it to kind of dictate what I want to have happen moving the geometry. Now, if you don't want that dimension to show up in the views because you'd like it to sort of, just be hidden or something like that, what you can do is a couple ways of doing that. Now, we can go ahead and hide all the dimensions in the drawing. Chances are in this floor plan we'll actually want to keep some of the dimensions showing at some point so we can actually use them. If this is one you want to just have hidden, what you can do is select it and just right click and say hide it in this view. Okay, and then it'll be hidden. It'll still be there, you just can't see it anymore. So watch out for this. Hidden things are always a little bit of a mixed lesson because they don't get in your way, you're not looking at them right now. If you want to see that dimension, you can either use the little light bulb to say, show me everything that's hidden, and kind of see where those things are. Or we might actually create 2 separate views that also, one that shows the dimensions and one that doesn't show the dimensions. So one more for display and presentation, and the other one for us to go working on. Either way, there's 2 ways to approach that. So sometimes we hide dimensions from ourselves. But even though it's a hidden dimension, they're working together. So if you go moving things in a model and things start moving together, you might unhide things or reveal the hidden elements. That way you can tell if there's something going on that's actually driving things that you don't know about. Okay. Now, this whole notion of kind of working with things like this is actually pretty cool. It's a good starting point in terms of what's going on, but let's kind of give you some more variations on the theme. For example, I'm going to put some windows across the front here and we'll play with them a little bit. I'll take some more of these windows, Maybe a different window. Let's see what else we got in here. Instead of those big fixed windows, how about if I get those archtop windows or something like that? There they are. Once again, I'll think about what the height is. Be conscious of this. This is always sort of a choice typically within a building. The head heights of the windows tends to often be very similar. Find out whether you're a 6'8", a 7 foot, an 8 foot. Everyone sort of has different assumptions about that. I'll just make them 6'8" because that's very common for a lot of residential stuff. And I'll go through and zoom on in and place some windows here. Okay, so I'm going to place a window here, again pulling to the outside, place a window here. If it turns out that you have placed some windows and you want to really quickly sort of place some more, you can use something called the copy tool. The copy tool looks like this. If you go and choose the window and grab the copy tool, it'll let you basically place another one. Works very much like copying does in AutoCAD, where you choose an object, you basically choose a base point on the object, which is really like a handle, and you place it.
So that's one quickie way to get a bunch of different windows. Now, in terms of thinking about all these different windows, I've got 4 windows kind of scattered around there. You might be saying, okay, well, that's kind of okay, but they're kind of randomly spaced out. I'd like to kind of get them to a very regular spacing. In fact, if you look at something like the exterior of the Y2E2 building, you'll find there's like a lot of very regularly spaced windows all the way across the entire facade. You tend to actually have pretty regular spacing. So how can you do that? You can go through and go to the annotate and put some dimensions down. And again, you can decide whether you want to dimension center to center or end to end. Okay, and that's how those windows are spaced out right now. And again, I can choose any of those windows. If I want this one to be 5 feet away, so it sort of matches the other side, I can say that. And I can start adjusting those dimensions manually to kind of make them be what they want to be. Different things we can do include, if you would like to maintain that relationship, I can lock any of the dimensions. I can decide whether I want to lock that 7'6" relationship, but let them slide around between the endpoints. Or I can decide whether I want to lock the 5 feet and let the middle part slide around. You can just really decide however you want to do that. Another thing that's really very useful, though, is that if you have a string dimension like this, there's this little guy right here called the equality constraint. What that's all about is that very often what we want to do is actually have very regularly spaced things kind of completely across the entire string. And what happens there is if you choose to turn on equality, okay, you get like completely equal windows. And the nice thing about equally spaced windows that are done this way is that if you move one of the windows, okay, you said the constraint that you care about is equality, so it's going to maintain that equality constraint no matter what you do to it. So let's pull that back out again. Now for this equality dimension, you have the choice. Do you want it just to say EQ? Do you want it actually to have it display the value? You can have it really just whatever way you want it to be. In fact, even in here, I should be able to say, let's do 6, 3 evenly spaced at 6 and kind of get it that way. Whatever it is, it sort of makes the most sense. But the equality constraints are very handy things for doing things like placing windows, the things that are a very regular rhythm. You get a whole bunch of columns that want to be regular rhythm. You have furniture to be placing that are regular rhythm. Like that over there.
Is the EQ supposed to show up on its own, or are you supposed to bring it up?
The EQ will show up when if you have a string of dimensions, then you have the option of EQ or not. So you mean in terms of like showing up from editing or showing up in terms of displaying?
In terms of being able to edit it.
Okay, so what will happen is,
it's if you have a string where it was all defined on one string, just if you click on that dimension, the EQ should be available as one of the options.
Okay.
So again, what that is that it's, if you do that, let me unconstrain it right now. If I did it as a series of separate ones, it wouldn't be there. For example, here to here, And then here, just zoom in. We'll get to a question here in a second. Okay, those look like a string of dimensions, but they're not really. That's actually two different dimensions. So at this point, the EQ is not available because I define them as two separate relationships. Okay, what you can do though is if you have a string, let me take out that one. If, for example, I have this first one and I want to make it into more of a string, what you can do is right click on this and you can say that you want to edit the witness lines. And what that'll let you do is basically add more to it. Okay, and that's making it more of, now it's a string. And then the EQ is available. What you got in the back row?
That's what I was going to ask, if there was a way to add on.
Ah, very good.
Just right
You can right click and say edit the witness lines. Another thing you might want to do is if you want to get rid of a witness line, you can right click on that little dot and say delete a witness line or move it. If you want to have the dimension not to the center, but you actually want it to dimension to the side, you could do that too. You could sort of choose whatever point of reference is the most interesting to you. Now, this whole idea of copying and equality relationships and things like that, it's such a powerful concept. We do an awful lot in building architectural work. There's actually a special tool just to help you with that called the array tool. And it really is, it's the best of copying, dimensioning, and locking all in one tool to kind of make it happen pretty quickly. And let's think about how you could use that. Because that is really, where you get some real power and the ability to do things very quickly. I'm going to look at that front facade over here, and I again will put some windows on there. Let me go ahead and put one here. Yeah, let's just kind of leave it there for now. Okay, I want to put a whole series of windows across this front facade and have them regularly spaced out in some nice pattern. Okay, so what can I do? I can go through and choose one of those, and instead of copying and putting all the dimensions in there, if I really know it's going to be very, very regular, I can use this guy right here, which is the array tool. So it's like like 4 squares where there's a little black one and 3 little blue ones off the side. And how arraying works is like this. I can choose the array tool, and then I have the choice of a couple things. Is it a linear array or is it a radial array? So moving on down a wall or a line of columns is linear. If I want to put a lot of chairs around a table, that's more radial. We'll choose a center point and radiate them around that. Group and associate is kind of an interesting one. Grouping and associating says, as I copy all these things and place them there, am I sort of scattering, placing them and letting them be independent after I place them, or am I going to keep them all connected together? If I keep them all connected together after I place them, I can continue to sort of tweak the dimensions. They're actually also clones of each other, so that if you change any one of them, all the other ones will be cloned to have the same object. Okay, so I generally group and associate. You have the number of things you want to put, and you have the choice of, are you going to specify the second instance or the last instance? And the difference is going to be, if you specify the second instance, it will keep on repeating that same increment and go on down the street that way. If you say do the last one, what will happen is you'll choose this one and the end point, and it will distribute them evenly at whatever spacing is necessary to kind of achieve that. Okay, so with all that as a preamble, let's just do it. Let me say last. I'm going to put, say, 5 of them in here. I'll choose a handle on this one. I'll locate it at the other end of the array. Okay, and there's 5 of them. Now, notice there's actually a little bar attaching them all. So I can try different variations. They're arrayed in groups, so if I want to try 7 of them instead, if I want to try 9 of them, if I want to try 10 of them, you can try and see how many you actually get in there. Okay, it'll sort of work. And the nice thing is, since they are arrayed and they're going to operate as an array, if you choose any one of them, for example, I'll choose this one and pull it on down. Notice it's going to still maintain that equality constraint. So if I change any of them, it's actually going to go through and say, okay, between this endpoint and that endpoint, go ahead and kind of give me the number that you want. And it's an array, so if it turns out that 10's looking a little bit too rich for your blood, change it to 8, whatever it is, and you sort of really quickly can go ahead and put things across the side. So get a lot of that. Arraying is just a really, really cool tool. Yeah.
on the array, you set the constraints to the two ends of that wall, is that right? How do you do that again?
Well, actually, I just actually placed the two windows. So it's not actually to the end of the wall, it's actually to the center line of the window. So I'm still placing the windows independent of that. What I might want to do, and this is kind of an interesting, you're onto a good issue here. If I want to have a relationship between the end of the wall and the different endpoints, what I need to do is basically put an array dimension like this. Okay, and I could also put a dimension like this. See if I can get this out of here again. I'm trying to get to the end of the wall. I might have to tab to do it. There we go. So what I should be able to do now, let's see if this will work. If I say I want that to be 6 feet away from the wall, what's it going to do here? It's thinking. Sometimes this happens. Watch out with this. This is something that's sort of constrained in a number of different ways. Rather than showing me all the different dimensions, I have to say activate the dimensions to actually make them blue and editable. Let's see if this will work. We're definitely in, yeah, we're kind of in funny territory now. Let me say make that 6 feet. Okay, so it's maintaining the array, but I'm moving the endpoints of the array. Same thing over here. I could take this one, activate its dimensions, give it that same 6 foot relationship. Okay, I could lock those, whatever it is that I need to do, but I'm playing around, trying to like do that on 2 different things. So why is that 6 there? Activate. U. There we go.
So we can start doing that.
If we're good, you're testing me here. I'm going to lock that one. I'm going to lock this one here. Zoom out. In theory now, if I move this, yep, it's maintaining the 6 feet and spacing them. So it's kind of, constraints are a really good way to work in the long run. Okay, another use of arrays that I want to show you about that's really kind of a really good one is, yes?
I'm having trouble changing that dimension.
Which one? Oh,
When you put the one in the corner?
yeah. Let's try this. Go ahead and click on the window first, because it's really, what it is you don't change the, you basically choose the object that's driving the dimension, and then see if you get like an activate dimensions. Okay. If you click on that, that should then make the different dimensions that apply blue. And when they're blue, you can edit them. No worries. Oh, it's tricky. Now, that's actually a really good example. I've never kind of built the wall that way, but that's actually a good way to do it with the end constraints and the middle constraints, and that'll be pretty smart from here on out. Okay. Another case of array I just want to tell you about that's kind of a really cool one is, for example, if you were going to go ahead and lay out an auditorium or a dining hall or a classroom, something like that, we often use the array to lay out seats and furniture and things that are sort of very regularly spaced. So let me show you what that might look like. I'll go to the architecture tab, and it turns out furniture is just another component. Doors and windows are special purpose components, but they're sort of a general component tool. And if you choose the general purpose component tool, you'll see that, in this, there's like a desk loaded. There's nothing else, parking space, deciduous tree, things like that. In the little starting point file that you have to work with, there's a few more things, but I'm going to go out to the library and pull in some other furniture. In my seating, I actually found, there's a little like, a tablet armchair. This will bring back memories of high school. We'll put that thing in here. I will put this component in. Notice when you're placing a component, as you put it in there, it may be a little hard to see there because it's not really sort of zoomed in. Let me see if I can zoom this in a little bit. I got it there. Notice that it is sort of facing one particular direction. If I hit the space bar, I can rotate it around and give it some other dimensions. I can always rotate it after the fact, but I'm going to rotate it so it's facing down instead. I got one of them in here now. So now I would like to create an entire row of these. Okay, again, I could copy them and start playing with all the dimensions, but probably the easiest way to do that is just grab one of them, choose the array tool, And then I'll say, okay, let me group and associate, linear, that's fine. Let me guess there's going to be about 8 of them in the row. Okay. And then I can try, well, no, I might be able to fit more than that in the row, maybe 12 of them. Okay. You can also go through and make arrays of arrays. So I can go through and take this and say that, okay, I'll do to the end there. Then I'll figure out how many rows I think I can fit. Okay, and real quickly populate a classroom, something like that. So just array is a good tool. Kind of file that away in your bag of tricks, because when you kind of create a lot of very repetitive things, it's a good one to work with. Okay, next up, what I wanted to do is really just dive into floors and roofs. And you're going to find those two are amazingly similar concepts in terms of what you need to work with. For working with them, there's just a couple of big rules you need to kind of keep in mind as we go. And let me kind of get those outlined for you. Shh, hang on. Okay, oops, there. Shh, wait. Let's pop that back over to the center screen. When we're going through creating floors, it really is kind of a very simple sort of operation. Looks sort of the same for roofs. In the same way that when we go through to create a wall, we draw a single line, and after we draw that line, a wall is created that kind of meets the different type characteristics we gave it. To create a floor, to create an area, okay, as opposed to a linear thing, what we do is we basically trace the boundary of an area, okay, and it'll fill in floor between those things. Okay. So what we're going to do is actually just go through and draw some sort of different shapes, and then as long as we go through and create a closed boundary, when we say finish, it'll fill that in with the floor area. Okay. So to do that, let's even as a starting point, I'm going to go ahead and put a floor outside of the building right now, just because it'll be a little bit easier to see what's going on. Then we'll put one inside. So for the floor, how it works is over here in the architecture tab, you'll find wall, door, window, those things. Floor, roof, and ceiling, they're all together because they actually work very similarly. We'll sketch a boundary, and then you create something within that boundary. So I'm going to say let's do an architectural floor. Just a floor, the plain floor, that'll work the same. Let's take a look at what comes up available as tools. So, as we're drawing, very similar to most other sort of operations, we have some drawing tools. We can draw lines, we can draw rectangles, we can pick walls. We'll talk about that in just a minute. So it's a very powerful way to do it. We choose the type of floor, and we can also pay attention to where the floor extends in the wall, whether it goes to the surface or goes to the core. And we'll talk about that relative to between walls. But for now, let's just go ahead and kind of create a floor on the outside of the building, just so we sort of get a sense of just closing the loop. And then we'll go through and put one inside. So I'm going to choose a drawing tool and choose a type. I'm just going to make it something like this wood finish floor. It doesn't make sense to put that on the outside, but you'll see it as we do it. And out here, I'm going to basically just start drawing a shape. Okay, and the important thing you want to do is close the shape. It's very important that that shape gets closed. It has to be a closed boundary to generate space, or to generate a floor. So, here we got my floor. You'll notice that one side actually has some parallel lines running around the outside of the boundary. Those parallel lines are indicating directionality of the framing elements. So if there's joists in there, that's the direction of the framing. We'll talk about how to change that too. But for right now, let me just go ahead and finish that floor by clicking the check mark. And you'll see a floor is created. Let me look at that in 3D just so you get a better sense of that. I'll shade that. So here's my basic floor. Now the floor has a type, so you can go ahead and choose that floor and play with its type. For example, right now it's a wood frame floor. If I want to make it a carpet floor or something like that, I can just change its type. Okay. You can also go through and for that floor give it an offset. Right now it's right at level 1,
Level 1 is typically the height of the subfloor. That'll probably be pretty good if that's inside the building. If this is outside the building, I was doing this as a concrete patio. I'd probably actually drop it down a few inches, just so I have a little bit of room for the water won't flow into the building. Yeah, so landings and things like that are typically to recess just a little bit. Okay, I got the basic shape there. Let me kind of tell you about the only things you have to worry about relative to floors, because floors actually work out to be pretty easy. Once I've chosen this floor, I can edit its boundary. Take a look at how it's defined again. There's really only a couple ways you possibly get in trouble with floors. Yes?
I want to choose floor and just use the same drawing.
Okay, let me go take a look at what's going on. Sometimes it's that you're in the middle of an editing mode, and sometimes it's just frozen. Now, Rich, can you cancel out of it? So it looks like there is something going on. Say no. Close again. Go to the drawing tools up here. So that one actually goes. I think it'll let you do it now. What happened is you were picking a wall, and there wasn't a wall you were picking on. Now you're drawing the boundary. So, that'll be okay. Okay, so when you draw, and we'll do that one first, then we'll pick the walls. Here's the only thing you have to worry about. I got my little pink boundary here. It's a nice closed boundary. Things are good. The only way you get in trouble is if something like this happens. Okay, or sometimes you got that little bit where they don't quite join together. The problem is it doesn't know what to do with that. It doesn't know how to close that. It can assume, but it's going to complain at you and say that, hey, I can't make a floor out of that. When you try to close that, it'll say the lines must be in closed loops, and it'll even try to tell you what needs to happen. Sometimes it's a little hard to spot because it's so, it's maybe small relative to the scale of the drawing. But what it wants to do is just close that up. The other variation you need to know about that we sometimes get in trouble with, it could look like this, it could look like that, is when you have an overshoot. Okay, again, it won't know what to do. It'll say, hey, now you have intersecting lines. Doesn't like those either. So we got to clean those up. Now, in terms of cleaning those up, there's a couple of different variations that'll help you. You can go ahead and just push those back, and that'll sort of work, but let me give you an even better way to do it. And it's one of my all-time favorite tools. It's up here in these modified tools. It's called the trim tool. And here's how the trim tool works. Trimming, it's very similar to what you may be used to in AutoCAD, but it actually has the opposite sense of direction. A lot of things in Revit have the opposite sense of direction. It's kind of funny that way. But here's how it works. When you're trimming things, what you want to do is basically select the different lines you want to trim against each other, but you want to be very careful to select the sides of the lines that you want to keep. Okay, so click on the edges you want to keep, not the part you want to have go away. So here's what I mean. If I want to keep this boundary in here, I'll click on this side of the line, and I'll click on that side of the line, and it'll trim it to keep them. Let me undo that. What not to do is click this side of the line and that side of the line, because then you'll lose pieces that you don't want. So remember to always click on the side you want to keep. Okay? And if you do that, hopefully you'll be in pretty good shape. So when you're drawing, it tends to be pretty easy to control this stuff. You can sort of see what you're doing. Hopefully you can clean up the boundaries. You just basically have to go through and kind of complete the boundary. Now, another variation I'll just let you know about when we're talking about the boundaries is if you want to create a hole in the floor because you want to put a big atrium in the building, or you want to put a hole for a stairway or a shaft or something like that, how you do that is you put another loop within the loop. So let me show you what I mean. This will create a hole in the floor. Okay, that'll be okay. When I finish that, it'll be a nice hole in the floor, everything will be super. Let me edit that again. This, it won't know what to do with. Okay, you can't have overlapping loops. They really have to be independent of each other. If what you really meant was nip the corner off, that's okay. We can sort of trim here and trim here. We can do some trimming to do that. But it can't handle overlapping loops. It only likes single continuous loops, so I can do this to this, and that to that. And then I still have a few extras over here, so I have to get rid of them. That'll work. But it has to be continuous loops. So just watch out for that.
Now, drawing floors out there in space may not be the most interesting thing. I may go get a patio and fire pit. But if we want to put a floor into the building, here's what you got to do. And what I will recommend for this is actually just go back into the floor plan view. And we'll use a slightly different variation on this thing. We will say, let me zoom on out, that what we want to do is choose a floor. But instead of just drawing the floor, a really good way to do this is this guy over here, the pick wall tool. The pick wall tool is really very, very incredibly useful because the pick wall tool, it'll find where the boundary of that floor is. It'll also lock the boundary of the floor to that wall. So if the wall moves around, the floor will move with it. So walls move, the floors automatically extend. So here's the way you work with that one. You choose the pick wall tool. That part's pretty good. The other thing you have to watch out for is this notion of extending the wall into the floor. Let's talk about that. Because that actually is kind of a very useful thing to do. The idea is, as you're creating your wall, just come on down, there's an interior surface, there's some sort of exterior surface to it. As you create the floor, the issue is, do you want the floor to come all the way out to the outside edge? Or do you want the floor only to come to the edge of the core and let the outside surface wrap on beyond it? Okay. And 9 times out of 10, you want to have it do this. You want it to wrap into the core and have the boundary, the exterior surface just wrap beyond it. Okay, so this should almost always be checked. This is almost always a good choice. You have the choice here about whether it should go to the outside of the core or go to the inside of the core. It's a very bad looking marker. This is sort of the issue of if you have platform framing where you have the floor inserted with the studs above and below, it goes to the outside core. If you're going to hang on a ledger on the inside, then you can get to the inside as you place the floor. But it almost always goes to the structural core. It rarely goes to the surface. So how that looks as you're modeling is you'll come on over here, we'll choose that pick wall tool. You'll say extend the wall to the core, and you'll pick some walls. And I'll just pick the walls on the outside of the building. And if you go zooming on in there, you might even notice it actually does a pretty good job of actually hitting the cores. Now, it's assuming the exterior face of the core. If you actually wanted to flip it around to be the interior face because you have some sort of construction that's going to hang on the core as opposed to extend into the core, what I can do is just choose one of those and let me find it. There it is. There's again some little arrows that let you flip. So I can move from the exterior to the interior face. But what happens is when you're done, you say finish that. Okay. And it'll put that floor underneath the walls. Okay, so let's take a look at that for a second. We'll say zoom out, maybe look at it in 3D. Okay, so go ahead, try putting a floor in there, see if you can sort of use the wall definition. One of the few times, and this is where you sometimes get in trouble, is sometimes when you're cooking walls, if the walls are just a little bit skew or they don't join quite right, sometimes you have to do a little bit of cleanup at the corner just to make that loop continuous. So sometimes when you're picking walls, if they just sort of miss by an inch or two, just use the trim tool to go ahead and clean up the corners. That's if you get in trouble anywhere, this is where it is. You pick walls and they don't quite join with each other, and you have to kind of finish joining to make a nice even boundary. But that's all you're driving for, is a nice even boundary. Okay, so go ahead and give that a try. Let's pause there for a second. How you guys doing in terms of floors? You got floors coming down, and they're looking pretty good. You able to pick walls and get your floors there? You pretty good? Yes, let's get some questions.
Do the inside floor, outside before you go to the house. How do you cut it out?
Say that again.
How do you remove the inside the outside floor?
Oh, that one over there? No worries. How you do that is it's just to put a second loop.
I'll grab this floor. I'll do it in 3D. Actually, you're gonna find out floors are one of the hardest things to grab, to edit, because their lines are right under the wall lines, so it's really hard to get at them. So I'll often go to the 3D view and grab them here. So I got the floor, and I'm gonna edit the boundary. And now I can go through, and if I draw just another loop inside, this won't be popular. You can create a big hole in the floor.
So that, just say that, and back here, let's go.
No, where do you select the boundary for? Or what tab?
Oh, what happens is as soon as you've selected the floor, it's kind of one of those weird ones where it'll only show up if the floor is selected. So select the floor, and then when you select the floor, you'll actually have, it says modify floors. From this is hanging off a little bit. So there's an edit boundary choice down. So it's only when the floor is selected. Watch out for that. There's definitely this weird thing where you know the command should be there. You can't figure out why it's not showing. Two things to watch out for. One is it may be that you have to have something selected to get that contextual menu. The other thing that will happen sometimes is if you get off the contextual menu, you'll be hanging around with a green tab and you can get back over it to finish it. So let me show you what I mean by that. This is kind of a real common thing to have happen. You're editing, everything's looking good. You go over here because you want to do some sort of annotation. Okay, everything seems to be gray, or a lot of it seems to be gray because there's not a whole lot I can do right now. And you're wondering, well, what happened to that check mark? I want my check mark back. I need to find my check mark. And the problem is, it is here. It's just back over on the Modify Floors tab. So you need to get back over to there, and then you'll find it. So the tabbing interface is good and bad. It tends to be pretty smart about being all of the contextual things, but you start going off path a little bit. Sometimes you have to go back and look for that green tab to make sure you get back in there. Okay, that is floors. Let's get you going with floors there, and let me give you a real quickie on roofs, because roofs are going to be so similar to floors, you're actually going to start thinking of them the same way. The only real difference you have to kind of think about relative to roofs versus floors, and here's the wall again. So floor, bring it on into the core, that's all kind of good. With roofs, the one thing you have to worry about, or there's two things you have to worry about. One is the issue of, typically we don't stop here right at the wall. We have some sort of an overhang. So you get to specify how far that overhang should be. The other issue you have to worry about is really, is this roof going to be sloping? So relative to this wall, is it going to be sloping up, or is it going to be flat, or just really what's going to happen? And that's where really all the beauty and the pain in roofs comes with, is really in those two different decisions. Because you can almost always get the walls. It's the issue of really kind of getting what you want by understanding how the sloping works. So let's show you how that works. I could do this, well, I'll go to level 2. Let's do it that way. That's probably better. I can show you how to edit it through the also, but I'll go to level 2, and here's the deal. We're going to create a roof. We're going to create it at level 2. All of us, at some point, you'll create a roof, you'll do it on the level 1 floor plan, and your roof will be on level 1. At which point you'll say, okay, I just need to grab that as an object and change it, give it a base constraint of level 2 as opposed to level 1. That's okay, you can do that. We all do this. You're on level 1, you draw your roof, it'll be at the wrong level. In fact, I think it'll even complain. I'm at level 1, if I say roof, it'll even say, this may not be the wisest thing in the world. Would you like me to put this at level 2 instead? Okay, so it's trying to help you. That's just a real common mistake people make. But no worries, you can always fix it after the fact. I'm going to go to level 2. On level 2, you'll notice that here's my plan. It's kind of ghosted out a little bit because, it's below us right now. We're underlaying, we're looking down on it. But I'm at level 2. I got the roof tool open, and we can start drawing. So how does this work with drawing? It works very similar to what we have been doing with the floors. We can go draw lines, we can pick walls. I'm going to pick walls because that's one of my favorite ways to do it. If you pick walls, you always have the choice of, does it define slope and is it overhang? So think about those. Okay. How much overhang you should have on a roof is really kind of an interesting architectural issue. Because really depending on your architectural style, you'll go all overboard about this. If you're a fan of prairie architecture and a lot of things that were done in the early 1900s, we had big old overhangs. It was an architectural style to have big old overhangs. So you'd find 36, 42, you'd find big old overhangs. It was really part of just an architectural feature. Okay? Post-World War II, when we were trying to build houses very economically, you'd find that they shrunk up. They got to be 8 inches to 16 inches or something like that. They became much, much smaller because it was saving a lot of material to go through and do that. And really what they should be really depends on what you want to have happen with them. Overhangs really do this. The nice thing about overhangs is they protect us from the rain coming down. So if we have rain coming down, it's not hitting our windows or not hitting our walls, so we have less of a waterproofing problem. The other thing they're really good for is the sun, and thinking about the sun, because the overhangs can shade us from the sun. Let me draw another drawing that may make it clear. So here's a roof like that. And we've started getting to be very, very careful about this, to think about how we can use overhangs, especially in the age of thinking about sustainability and passive design, because we've noted that if we want to go through and have sun able to enter the building in the wintertime, when the sun's very low in the sky, but sun be blocked out of the building, okay, when it's summertime and the sun's high in the sky, you can actually use the overhangs to do that. It's a really cool way of just providing shading so that we're not getting a lot of heat load from the sun on our windows during the summertime. So overhangs, you'll often find them on the sunny side of the building sticking out very far, and the distance really is determined by just how far out you need to be to shade the windows. Okay, so that's kind of the just general architectural rundown in terms of overhangs. We'll choose an overhang distance. We'll also choose a slope distance. Okay, as we think about these, I'm just gonna, as a starting point, say, oh, let's put an even 2-foot overhang all around. Again, not necessarily a good choice, but it'll get us started. I'm gonna say, let's extend this into the core. What's happening there, that's the issue, is as I measure the overhang, do I wanna measure from the face, or do I wanna measure from the core? And if you think about how they're actually gonna build it, they're probably gonna be measuring this from the core. You measure it from the face of the stud, not from the face of the finished material. Okay, so to the core is almost always a better choice. Okay, what we'll do now is just go ahead and pick some walls. These are all these little 2-foot overhangs. So even though I'm picking the wall, notice how it hangs out a little bit. That's looking pretty good. Okay, I've got a nice continuous boundary. If somehow your walls didn't line up in such a way that you have a nice continuous boundary, we're going to go ahead and do a little training. Because again, you need a nice peak continuous boundary, same as the rules for the floor. Okay, we can go ahead and adjust the slope of the roof, the overall slope. We can adjust individual surfaces in the overall slope. Let's talk about slope for a second. 9 and 12 means that you have a very steep roof. For every 12 inches here, we're going to have 9 inches of height. Okay. A 9-12 roof is a roof that says either I have a lot of slope or snow that I need to shed, or I have a big important house and I want you to notice it when you drive down the street. Okay. Yeah, so really, A-frames are taller than that, but very steep roofs, we tend not to build as much anymore unless you're making a statement house. People want those. A lot of modern architecture has very shallow roofs. When we were building a lot of the ranch houses in this area, it was either 4 to 5 inches. If you get to the really, the Case City houses, all the mid-century modern stuff, those would be 2 and 3. It was really, really very shallow in terms of what's going on. So, it's a really sort of an architectural style statement about what you want to be. I'm going to make this about, 5-12, which is kind of just sort of in the middle. It's kind of ranch house middling. I'll say apply to that. And when I finish, we also have a type. Things always have a type, whether I want it to be a generic roof or I'll make it a nice wood rafter roof with asphalt shingles. I'll say finish this and you'll see what happens. When we go out to 3D, you'll get a better sense of this. Oops. I put it down on level 1, as I told you not to do. I will choose it and say the base level really needs to be level 2 instead. Say apply it. Even though I switched to level 2, I think I was already doomed because I said make it on level 1. But if your roof ends up in the wrong spot, it's as easy as that, just changing the parameters depending on relative to where you want it to be. So I got my roof hanging around here. It's looking pretty good in terms of what's going on. We might realize it did an awful lot of complex geometry in terms of making that happen based on all these different surfaces and how you slope up towards the center. But it did a very nice job of figuring out for me where the ridge, the valley, all those different things are going to come together. The nice thing about basing things on the wall lines the way we did it though is, and kind of like I showed you yesterday, what'll happen is if we go through and move anything, for example, if I take this wall, and I move the wall out, or I move a wall in, whatever it is I'm doing, the nice thing is that roof is going to update itself and stay intact. So the nice thing about having a nice parametric model where everything is hanging on the walls is that if the walls move, the floor moves, the roof moves, you always have an intact building no matter what happens. Okay, and that'll look good in all the different views. So a couple other little less variations before we send you off for lunchtime that you need to know about roofs. Okay. This is a hip roof. This is sloping up from all different sides. It was kind of an architectural style that's been very popular, especially for residential construction. If you want to have a roof which is not a hip roof but has some variations to it, some real common variations look like this. We can choose the roof, and because it's chosen, we can say edit the footprint. I'll say edit the footprint, and we'll get back to that boundary line. I'm looking at that boundary line in 3D, but it's the same boundary line with it in 2D. If, for example, I wanted to go through and change one of these walls, so instead of having the roof slope up from that surface, it doesn't slope, I could choose that line, for example, this one, and just say, don't slope from here. Maybe I'll do the same thing over here. On this one, I'll say, don't slope from here. And when I finish, you get something like that. That's what we call a gable roof. So hip roof, these are gables on the end. And gables tend to work out pretty good. A lot of ranch houses were built this way. You know, the big trick with all this is just figuring out which side you want to have slope and which side you don't want to have slope. And what you should do is play around with, if you have it slope from a single side, like a shed roof, you have no slope, it's a flat roof. Just got to think about what is the slope that you want to have, you know, how you want to be shedding the water on your roof. Now, if you do a gable roof, let me point out kind of an important little thing you need to know about. That again is part of how the parametric stuff can work for you. You'll notice that, oh, at the gable end, we have a little bit of a problem right here. We got our heat flying out, we got our birds and bats flying in, we got a little problem over here. And what we need to do is kind of fix that. So, as you think about fixing that, you can think about that wall and how we can edit that wall and make a little triangular wall. It's going to do whatever it needs to do. And it's going to be a lot of work for me to do, and I'm going to dread doing that. Or you can think about this. If you choose that wall, okay, through the beauty of parametric constraints, okay, the notion that things attach to each other is kind of becoming pretty common in the way we're thinking about things. And one thing you do with walls is you attach their tops to things and their bases to things. So if you can think about that wall and attaching its top to a roof, I'll say attach its top, and I'll choose that roof. It'll fill that in for me. Again here, I'll choose that wall, and I'll say attach its top, and attach it to that roof, and again, it'll fill in the gap for me. Okay, and that's where it gets really kind of neat and interesting. Because what will happen is, oh, for example, if you decide to change that, and your client decides they are much more important and need a big roof to show it off, you know, the walls will go ahead and grow to do those things. Okay? Or even if you go through and change the wall types, for example, here's the wall type. As opposed to all that brick, this is a big old lakefront house. I want to go through and put a big glass wall here, and we decide to do that. I can choose to put a big old glass wall here. Let's see if it'll do it. It's going to complain to me a little bit because it actually got rid of some windows that it got rid of, but now I have a big glass wall there, and again, it's attached to the roof. You know, whether it is this size, or whether it's A-frame sized, whatever it is, I got a smart roof. Okay, so go ahead and between now and when we get ourselves together again at 2:30 or so, this is you, I think. Okay, when you come back at 2:30, see if you can, relative to your assignment, you know, get some walls down, get those sort of, you know, windows sort of placed on it. See if you can get a floor and start thinking about what your roof shape looks like, so we can answer some questions about some problems you might be having in the afternoon session. Also, we'll take a look at basically how we get these things and start to create the views, making floor plan views with dimensions on them, making elevation views and getting those on sheets. But between that and you can spend a little time just working on your shape. Again, it's only 500 square feet, don't over-design it. Okay, see if you can get a basic little building that's kind of together like this, then we'll have something to operate on in the afternoon. Okay, yes? No worries. Okay, what we did was, there were a couple of variations. The big thing was, when we went through and chose the roof surface, I chose the roof, and we said edit the footprint. There's the notion of the pink lines, and every pink line has the notion of whether it's sloping or not. So one thing I did was I removed the sloping. That actually sloped the roof up. Okay, that's the first piece. The second piece is, let me finish this out. Once you have that there, sure. Let me detach this wall, and I'll show you how we reattach it. I can say detach it. Okay, so here it is with a big gap. So when it's time to fill the gap, what I do is I choose the wall, and because I've chosen the wall, now we can modify the wall, and one of the choices is attach the top, and you can choose the object to attach it to, and then it'll fill in the gap. Okay, no worries. Okay, let's break for now, head on out, and we'll see you guys in just a little bit.